Last weekend we had some of the coldest weather of the season so far, and you might be wondering, why are we suddenly having these long stretches of below zero weather in the middle of February when you'd think it should be warming up by now? And that's below zero Fahrenheit, so for our non-American friends, that's around negative 18 Celsius. So basically, it's cold. And I know that's just inviting responses of, well, where I live it's negative 40 every day in the winter, and I'm wearing shorts and a t-shirt, so what are you complaining about? There's a meter of snow on the ground and Yes, I get it. I don't live in the absolute worst area as far as harsh winters go, but it's pretty bad. It's cold enough that they had to put out this graphic about what to do when it gets cold. Wait, avoid alcohol and caffeine? You can't tell me what to do, National Weather Service. So why does it so often seem that we make it through December and January without things getting too bad, maybe just barely below freezing, and then February gets here and we have these extreme cold snaps? And there are some exceptions to this, like the 2017-2018 cold wave, which happened in late December and early January. But around here, the coldest temperature ever recorded was on January 31st, at negative 33 Fahrenheit. Many other cities around the area set record lows on this day as well. There's actually a few factors at play for why we get these extremely frigid temperatures late in the season, and why in general, January, February, and March tend to be colder than November, October, and September before the winter solstice. Alright, so here's the Earth. Now, the real Earth is a little bit bigger than this, but this lets us see everything that's happening at once, so let's just go with this. Now, this represents daytime in North America on the winter solstice. This is the shortest day of the year in the northern hemisphere, and also is the day where the sun reaches the lowest point in the sky at solar noon. The sun being represented by my flashlight that's just off screen to the left here. Now, on the winter solstice, the part of the Earth that's receiving the most direct sunlight is at the 23.5 degrees south latitude. And that's because the Earth is tilted at 23.5 degrees relative to its orbit around the sun. So if you were standing on that 23.5 degree latitude south, then right at noon, the sun will be directly overhead at 90 degrees. But as you start going north from there, the angle that the sun hits the surface of the Earth gets lower and lower, and so the intensity of the sunlight also gets lower. And that's because the sunlight not only has more atmosphere to get through before it hits the surface, but also because you've got the same amount of light spread out over a larger surface area. So note how in winter, North America is all the way up here, so it's receiving much less sunlight than it is during the summer when it's down here. And then we also have the equinox where it's somewhere in between, and then the equator is where the direct sunlight is hitting. But today we're talking about winter. Just to interject here, it's a common misconception that the seasons are due to the varying distance between the Earth and the sun throughout the year. Although the distance does vary a little, it's actually during the winter in the northern hemisphere that the Earth is closer to the sun than it is 6 months later in the summer. So the actual distance to the sun doesn't have much of an effect on the seasons, at least not at the distance range that we experience. It has almost everything to do with the tilt of the Earth and how this affects the angle of the sunlight hitting your location. We can demonstrate the effect that the angle has on the intensity of the light using a simple flashlight. So take a flashlight and just point it perpendicular at the ground, and then note what the spotlight looks like on the ground. Now, without changing the height of the flashlight above the ground, just kind of angle it back like this, and you'll see that the spotlight starts to spread out and gets dimmer as well, indicating that a specific point within the spotlight is now receiving less intense light than what it was initially. And now, back to wherever we were before I interrupted. Now, if we start going north still, we'll eventually get to the Arctic Circle, and that is at 66.5 degrees latitude north, and that's 90 degrees minus the 23.5 degree tilt. If you're north of the Arctic Circle, then on the winter solstice, the sun never rises at all. It never gets above the horizon. And you can kind of see why that is, because, if the sun is back here, as the Earth rotates, no matter what time of day it is, the sun can never reach this part here inside the Arctic Circle because it's always behind the curve at the top here, which on the solstice is right at the Arctic Circle. So this will be important later. So why is it that if the sun is the weakest in the northern hemisphere at the end of December, does this not usually correspond to the coldest temperatures of the year? This mostly has to do with the Earth's ability to retain heat for a certain amount of time, even after the intensity of the sunlight we receive diminishes, and this is mostly thanks to the atmosphere. The Earth is constantly receiving energy from the sun and also radiating energy back out into space. However, the rate that the heat is lost to space is not instantaneous, so we should expect a delay between when the sunlight is weakest in a particular area versus when the temperature is the lowest. Otherwise, it'd be freezing every night, even in the summer. In fact, if the sun were to completely disappear, which fortunately it doesn't seem like that's something that could actually happen, but if it did, the Earth wouldn't immediately plummet into absolute zero temperatures, but it would continue to hold on for quite a bit of heat long after that last ray of sunlight struck the planet. The final thing to consider is the polar vortex. Now, you might have heard them talking about this in the news or on the Weather Channel, but because the North Pole is receiving basically no sunlight during the winter, during this time, the air there can get very, very cold. And normally this extremely frigid Arctic air stays put, held in place by the polar jet stream. A jet stream is just a very fast-moving current of air that circles the planet. But what happens if the jet stream weakens temporarily or takes on a more wavy path across the Earth? This allows some of that Arctic air to start moving southward into Canada and the United States, and on the other side of the world into Europe and Northern Asia. And this is when we get these extreme cold snaps, such as what we've been seeing in the past week or so. So thanks, North Pole, for sharing your ridiculously cold air with the rest of us.